Welcome to our video on decision trees and rule-based systems. Today we'll explore how these two powerful tools help us make sense of complex choices and automate decision-making. Whether you're new to artificial intelligence or just curious about how computers mimic human reasoning, this video will break down the basics in a clear and engaging way. We'll start by introducing decision trees, a popular method for visualizing decisions and their possible outcome. Then we'll dive into rule-based systems which use logical rules to reach conclusions. By the end, you'll understand the strengths and uses of both approaches. Decision tree is a flowchart-like structure that helps us make decisions by mapping out different choices and their possible consequences. Imagine a tree where each branch represents a decision or a possible outcome. At each node, you answer a question or evaluate a condition, and based on your answer, you move down a branch to the next node. This continues until you reach a final outcome or decision. Decision trees are widely used in fields like finance, healthcare, and machine learning because they make complex decisions easy to visualize and understand. A decision tree, the main components are nodes and branches. Each node represents a decision point or a test on an attribute, while branches show the possible outcomes of that test. The top node is called the root, and it's where the decision-making process begins. As you move down the tree, you encounter more nodes and branches, each representing further decisions or outcomes. This structure allows for a step-by-step breakdown of complex problems, making it easier to follow the logic behind each choice. At the end of each branch in a decision tree, you'll find a leaf node. Leaf nodes represent the final outcomes or decisions after all the choices have been made. These outcomes could be a classification like approve or deny, or a specific value such as a predicted price. By following the path from the root to a leaf, you can see exactly how a decision was reached. This transparency is one reason why decision trees are so popular in data analysis and machine learning. Building a decision tree involves selecting the best questions or tests to split the data at each node. The goal is to organize the data so that each branch leads to a clear and distinct outcome. This process often uses algorithms that measure how well each split separates the data, such as information gain or Gini impurity. By carefully choosing splits, we create a tree that accurately reflects the decision-making process and helps predict outcomes for new data. Decision trees offer several advantages. They are easy to understand and interpret, even for people without a technical background. The visual structure makes it simple to follow the reasoning behind each decision. Decision trees can handle both numerical and categorical data, making them versatile for many applications. They also require little data preparation compared to other methods. These strengths make decision trees a popular choice for many real-world problems. Despite their strengths, decision trees have some limitations. They can become overly complex if not properly managed, leading to overfitting where the tree matches the trained data too closely and performs poorly on new data. Decision trees can also be sensitive to small changes in the data, which might result in a completely different structure. To address these issues, techniques like pruning or using ensemble methods such as random forests are often applied. Now let's shift our focus to rule-based systems. These systems use a set of if-then rules to make decisions or draw conclusions. Each rule specifies a condition and an action. If the condition is true, the system takes the specified action. Rule-based systems are widely used in expert systems, automation, and artificial intelligence because they can encode human expertise in a structured way. They are especially useful when decisions can be clearly defined by logical rule. Typical rule-based system consists of three main parts: a knowledge base, an inference engine, and a user interface. The knowledge base contains all the rules and facts about the problem domain. The inference engine applies the rules to the facts to draw conclusions or make decisions. The user interface allows users to interact with the system, inputting data and receiving results. This modular structure makes rule-based systems flexible and easy to update as new rules or facts are added. Rules in a rule-based system are typically created by experts in the field. Each rule follows an if condition then action format. For example, in a medical diagnosis system, a rule might state, if the patient has a fever and cough, then suggest a flu test. By combining many such rules, the system can handle complex decision-making tasks. The clarity and modularity of rules make it easy to update or expand the system as new knowledge becomes available. Rule-based systems are used in a wide range of applications. In healthcare, they help diagnose diseases by following medical guidelines. In finance, they automate credit approval by checking specific criteria. Rule-based systems are also common in customer support, where they guide responses based on user queries. Their ability to encode expert knowledge and automate repetitive decisions makes them valuable in many industries. One of the main strengths of rule-based systems is their transparency. Each decision can be traced back to a specific rule, making it easy to explain and justify outcomes. Rule-based systems are also highly flexible. New rules can be added without redesigning the entire system. They are especially effective in domains where expert knowledge can be clearly defined and encoded as rules. Despite their advantages, rule-based systems have some limitations. They can become difficult to manage as the number of rules grows, leading to conflicts or inconsistencies. Rule-based systems also struggle with problems that require learning from data or adapting to new situations. For tasks that involve uncertainty or complex patterns, other approaches like machine learning may be more effective. Now that we've covered both decision trees and rule-based systems, let's compare them. Decision trees are great for visualizing choices and outcomes, making them ideal for data-driven tasks. Rule-based systems, on the other hand, excel at encoding expert knowledge and handling well-defined rules. While both can automate decisions, the choice between them depends on the problem at hand and the type of data or expertise available. Decision trees are best used when you have structured data and need to make predictions or classifications. They are especially useful when you want to understand the reasoning behind each decision, as the tree structure makes the logic transparent. Decision trees are also a good choice when you need to handle both numerical and categorical variables in your data. Rule-based systems are ideal when decisions can be clearly defined by logical rules and expert knowledge. They work well in environments where the rules are stable and don't change frequently. If you need a system that can be easily updated with new rules or explanations, rule-based systems offer the flexibility and transparency you need. Some cases, decision trees and rule-based systems can be combined to create more powerful solutions. For example, a decision tree might be used to classify data, and then a rule-based system could apply specific rules to handle exceptions or special cases. This hybrid approach leverages the strengths of both methods, providing flexibility and accuracy in complex decision-making tasks. Let's look at a real-world example: medical diagnosis. Decision trees can help doctors classify symptoms and suggest possible conditions based on patient data. Rule-based systems can then apply medical guidelines to recommend treatments or further tests. By combining both approaches, healthcare providers can offer more accurate and personalized care to patients. In finance, decision trees are used to assess loan applications by evaluating factors like income, credit score, and employment history. Rule-based systems can then enforce specific lending policies, such as maximum loan amounts or required documentation. This combination ensures that decisions are both data-driven and compliant with regulations. Customer support systems often use decision trees to guide agents through troubleshooting steps based on user input. Rule-based systems can provide automated responses or escalate issues according to predefined rules. This approach streamlines support processes and ensures consistent, high-quality service for customers. Decision trees can be built automatically from data using algorithms like ID3 or CART. These algorithms analyze the data to find the best questions to ask at each node, aiming to split the data into groups that are as pure as possible. This learning process allows decision trees to adapt to new data and improve their predictions over time. Rule-based systems use inference engines to apply rules to facts and draw conclusions. There are two main reasoning methods: forward chaining and backward chaining. Forward chaining starts with known facts and applies rules to infer new facts, while backward chaining starts with a goal and works backward to find supporting facts. These methods help rule-based systems solve complex problems step by step. Both decision trees and rule-based systems can struggle with uncertainty or incomplete information. Extensions like fuzzy logic or probabilistic rules can help address these challenges. For example, fuzzy logic allows rules to handle partial truths, while probabilistic decision trees can estimate the likelihood of different outcomes. These enhancements make the systems more robust in real-world scenarios. Maintaining decision trees and rule-based systems involves regularly updating them with new data or rules. For decision trees, this might mean retraining the model with fresh data to improve accuracy. For rule-based systems, it involves adding, removing, or modifying rules as new knowledge becomes available. Regular maintenance ensures that the systems stay relevant and effective. One of the key benefits of both decision trees and rule-based systems is their interpretability. Users can trace the steps taken to reach a decision, making it easier to understand and trust the results. This transparency is especially important in fields like healthcare and finance, where decisions can have significant consequences. As the amount of data or the number of rules grows, scalability becomes a concern. Large decision trees can become unwieldy, while rule-based systems may face performance issues as rules increase. Techniques like pruning, rule optimization, or using more advanced algorithms can help maintain efficiency and performance as systems scale. Decision trees and rule-based systems are often integrated with other technologies, such as databases, web applications, or machine learning models. This integration allows them to access real-time data, automate workflows, and provide intelligent recommendations. Seamless integration enhances their usefulness in modern business environments. In using decision trees and rule-based systems, it's important to consider ethical issues such as fairness, transparency, and accountability. Decisions made by these systems can impact people's lives, so ensuring that they are free from bias and easy to explain is crucial. Regular audits and transparent design help maintain ethical standards. Future of decision trees and rule-based systems includes integration with advanced AI techniques, such as deep learning and natural language processing. These advancements will enable systems to handle more complex data and provide even smarter decision support. As technology evolves, these foundational tools will continue to play a vital role in intelligent automation. Summary: decision trees and rule-based systems are essential tools for automating decisions and making complex choices more understandable. Decision trees excel at visualizing data-driven decisions, while rule-based systems shine in coding expert knowledge. By understanding their strengths and limitations, you can choose the right approach for your needs or even combine them for more powerful solutions. Thanks for watching, and we hope you now have a clearer understanding of these important concepts.